We've got today in our class, I've got a lesson planned for you that's a continuation of Tuesday's lesson. We're going to pick up with more word problems. And you'll remember, what did we use to help us kind of organize the information in these word problems? You guys remember on Tuesday?
A chart.
We used a chart. Very good. We used a chart to help us organize the information, and that's what we're going to try and use again today in a couple of examples. You can get away with working a problem without a chart, but especially early on, I think it's extremely helpful to make use of a chart. And so that is what we are going to do today. I gotta get my roster out. Hold on just a second. Perfect. And so you read this example 2 with me here, and what you'll note is that there's 2 rows. There's 2 specific, I guess, categories is a good way to describe that. In this case of stamps, there's 2 categories of stamps. You've got a 35-cent stamp and a 49-cent stamp. And so what we want to do today is we want to set up our chart where each of those types of stamps gets a specific row. All right, so go ahead and start drawing your chart. I'll do the same for myself. And remind me, Lewis, what goes on the top of that chart? What's sort of operating in our background here?
Is it like rate and like quantity?
Okay, so good. We got rate. We got quantity. What else?
Total.
Beautiful. Total. And Paul, what's the relationship between those 3 words? Rate, quantity, and total.
In
other words, what do we do with them?
What do we do with them? Rate times quantity equals total.
Yeah, very good. So we're going to multiply rate times quantity, and we're going to set that equal to the total. Okay, this is like if I went to, my kids like going to the Oakland Donut shop. Okay, we live out in Fayette County. We drive through Oakland every morning, or at least they do with their mama on their way to school. And, they'll sweet talk her into stopping at the donut shop every once in a while. And so Teddy likes to get these things called kolaches. Y'all ever had a kolache before? You know what a kolache is? It's pretty much like a donut with a breakfast sausage shoved in the middle of it. Okay. And so it's like a giant pig in a blanket. The girls like to get these donuts. I don't know how to describe it, but it's like a donut that's got like these little slits that are cut in it, and then inside it is like this strawberry cream that's on the inside. And then Mrs. Morgan likes to get the normal regular old thing. And so like what do they do when they ring all my kids and my wife up? Well, they see how many kolaches we got times how much a kolache costs. How many of those little Betsy and Jenny type donuts they've got times however much those cost. And then however many Mrs. Morgan kind of donuts. She likes the chocolate with sprinkles. How much of those cost, and then how many they bought of those. And at the end, what do? They tally all of that up. So it's rate times quantity plus rate times quantity plus rate times quantity equals the total. Okay, and that's how we write up our equation for all these problems. So our total right here we know is going to be 1575. Okay, so we're going to have rate times quantity plus rate times quantity equals that 1575. Okay, and so our job with using this chart is to figure out, well, what is the rate of my first type of stamp? What is the quantity of my first type of stamp? What's the rate of my second kind of stamp? And what's the quantity of my second kind of stamp? And if we can figure out those 4 parameters, we've got step 3 of our word problem solving method taken care of. We've got our equation written down. Okay, so I hope that makes sense to you guys as far as like what we're trying to do here. Now, the chart is not going to do it for us, but it's going to allow us, it's going to help us to figure out what we need to put in there. Okay, so obviously the first column is going to be known. We know how much a 49-cent stamp costs. It's 49 cents. All right, and we know how much a 35-cent stamp costs. It's 35 cents. Now we don't know what the quantity is. That's actually what they're asking us. So when we do our 5-step problem solving method, and we read the problem, first step to figure out what they're asking, that's exactly what we have determined now. They're asking me the quantity of each. So I should let my unknown stand for that quantity. Okay. I should let my unknown stand for that quantity. But yesterday, I think we had said I tend to have more success when I let the smaller quantity be my unknown. So you guys tell me, as you read this, I've heard from Paul, I've heard from Lewis. Let me hear from somebody else now. When I read this sentence that's highlighted in green, which one is there more of, and which one is there fewer or less of? It says the number of 49-cent stamps is 5 less than 3 times the number of 35-cent stamps. So which one do you guys think there's more of?
49-cent stamps.
Yeah, I agree, right? It is as though we're saying 49-cent stamps. If we, I don't know, we just call this X if you guys want to. 49-cent stamps is 5 less than, so we would say take 5 away from, and then 3 times, maybe we will call this Y, I don't care. 3 times Y. So if I let my unknown, let's just call it Y, if I let my unknown stand for the number of 35-cent stamps, then I can use this expression right up here to stand for the number of unknown number of 49-cent stamps. So 3Y minus 5. I really don't care what letters you use. They're just dummy variables, but you guys get the idea, where if I let my smaller quantity equal the variable, then I can express my other unknown in terms of that variable. And that's the important part there. Okay, so very good. Will Edwards, what do I do from left to right?
Write an equation.
Yeah. But I'm looking in green over here. Like, what do I do with these two things?
Multiply.
Yeah, very good. We're going to use our distributive property. We're going to multiply. So 0.49 on the outside, and we got 3y minus 5 on the inside. Same thing over here. We got 0.35y. And fellas, that's what we're going to do to set up our equation, as William just mentioned. Okay, so we got 0.49 3y minus 5. That's how much money that Danny paid for this first type of stamp. 0.35y, that's how much money Danny paid for the second type of stamp. And he goes to the register and she adds all that up. They tally all that up, just like the donut shop. How much you got for this kind of donut, how much you got for this kind of donut, how much you got for this kind of donut, ring it all up, ring a ding ding, and you got your total. Okay. All right, Charlie, what do I do to get rid of all these dirty old decimals? I don't like these decimals, Charlie, so help me get rid of them.
Multiply by 100.
Yeah, very good. We're going to multiply by 100. Okay. We're going to multiply by 100. Now, 100 on the left and 100 on the right is going to get the job done. When I multiply 100 times 15.75, I get 1,575. That's nice. When I multiply 100 on the left, I missed that last one. We're going to distribute times both of those terms. So 100 times 0.49 is going to be 49. And 100 times 0.35 is going to be 35. Please don't over distribute. Please don't multiply 100 times 49 and times 3y and times -5. That whole first term gets the 100 just one time. That whole second term gets the 100 just one time. And then the whole third term gets the 100 just one time. We don't want to over distribute. Okay, but this is a much more preferable equation now on the bottom here that I've got in orange, because there's no more decimals. So what we can do is we can just simply combine like terms. 49 distributes times 3 to give us 147. And then 49 times 5 will be 245. Y'all double check my arithmetic on that, please. 35y, 1575. So the arithmetic look all right to you guys? Give me a thumbs up or give me a head shake, something. Okay, good, Chuck. Thank you. All right, Jake, combine some like terms. What do we get?
Um, 147 plus 35, which is 182.
All right, so we got 182. Y. I'm gonna go ahead and add 245 to the other side. Have you guys done that yet? We get 1820. Oh, and that divides nicely, doesn't it? Y equals 10. Okay, John Zweig, we're not done with the problem, though. What else do I have to do now?
Answer the question.
Speak up.
Answer the question.
Yeah, answer the question. They want to know how many types of each stamp did we get. So in other words, we figured out this cell. Now we still need to figure out this other cell. That's the easy matter of just plugging in y equals 10. So 30 minus 5 is 25. So x equals 25. Now, it wouldn't be, if I were turning this into like my math teacher, you guys have your 8th grade math teachers, I wouldn't write my answer up like that. I would say something to the effect of, okay, there were 25 49-cent stamps, and there were 10 35-cent stamps. Just spell it out for them so they don't have to be wondering, what each letter stands for. So go ahead and spell it out for them. All right, now I've got that example. We got that example in the books, okay? And I've got one down here about whale watching tickets that that you guys need to do on your own. So let's about 3-4 minutes. You guys sit quietly and just kind of grind example 3 out. And don't be ashamed to use a chart. It helps you write your equation. And then once you get your equation, solve it out. Show each step that you're doing. Don't try and just do it in your head, okay? Joey, you got your chart set up yet? Joey, you got your chart set up?
Not yet.
Yeah. All right. What do you want to do for that very top? What's your formula? Still talking to you, Joey.
Rate times quantity equals total.
Good. We got rate, quantity equals total. All right. And Joey, help me out again. What goes on my first row? What is my first row all about? What types of things are we dealing with? And we're not dealing with stamps, for example.
Money.
Okay. Yes, that's true. As you read the problem, there's going to be 2 different types of things that we are purchasing with that money. What are the 2 different types of things?
Tickets.
Okay, so you got full fare tickets.
Reduced fare.
And you got reduced fare tickets. Okay, so we're just going to say full fare tickets and reduced. All right, so if you guys were having trouble setting up your chart, again, like a jigsaw puzzle, start on the border, you know, figure out, we should know, everybody should know rate, quantity, total, and then also figure out, well, okay, what are we dealing with? Are we dealing with, you know, raisins and nuts? Are we dealing with two different types of donuts? Are we dealing with stamps? Are we dealing with tickets? You know, so that's how we will put our chart together. And then remember, we know one full column, and there's going to be one column where we don't know. Okay. So Joey's off the hot seat. He's helped me enough. Let's see about Reed. Can you tell me, Reed, anything about the rate column? And this is helpful when you guys have y'all's cameras turned on so I can see you if you've got a camera that works.
Like how much they paid?
Yeah. Okay. So how much does a full fare ticket cost?
$32.
And the other kind?
26.
26. Good. Remember, fellas, you'll always know everything about one column. It's not always the rate column. It just happens to be that way in this example. But the unknown then will be in the other column. So we don't know how many full fare tickets there are. We don't know how many reduced fare tickets there are. But we do have enough information. Y'all don't need that last example on the screen anymore. You've had time to do that. Let's see if I can get this ribbon pulled back up. We do have enough information to compare the two of them together. Okay. And what I mean by compare the two of them together is like if I said, you know, let X be the number of full tickets, how could I express the number of reduced tickets? Well, I'm going to need to use that 40 somehow. Okay. For example, let's say I've got 25 of you guys in my class and 7 have blue eyes. How many don't have blue eyes?
$18.
Yeah, that's right, Quentin. How'd you get that?
I subtracted 7 from 25.
So there's this notion, you guys write this formula down. There's this notion, part 1 plus part 2 equals the whole. And if I don't know one of those parts, what I could do is I could subtract. I could say, oh, let's say I don't know what part 1 is. Well, part 1 I could express as the whole minus part 2, or vice versa. We could say part 2 equals the whole minus part 1. So like, for example, if I know there's 25 guys in class and I know 7 of them have blue eyes and I don't know how many don't have blue eyes, I could just subtract the whole minus the blue-eyed guys. That's the notion that we're using here. So if I know that there's 40 passengers altogether, there's been 40 tickets that were sold, and X of them were full tickets, how many are reduced tickets, class? Somebody say it.
40 minus
Total
X.
minus X.
Yeah, very good, very good. That's the idea of the whole 40 minus the other part, in this case, X, and that's how we can express the other unknown. That's a tricky little challenge for us, isn't it? So be able to use, you know, this notion of, I can call it the blue-eyed principle, right? Be able to use this notion of, if I know the whole, I can subtract one of the parts, and that way I can express the other part. And then you guys ought to be able to take this and run with it. From left to right, we, from left to right, we multiply, right? So we got 32X, and we got 26 quantity 40 minus X. So I'm going to ask a strange question, perhaps. I'm going to say, what is 32X? Well, 32X is the amount of revenue that this, you know, whale watching venture earned on full fare tickets. It's the amount of money spent for full fare tickets. Okay? And what is 26 times quantity 40 minus X? It's the amount of money spent for reduced fare tickets. Okay? Now, what do I make of that? Well, I've got an equation over here that I need to write, and I'm going to use this. It says the total revenue. In other words, after I calculate how much money I earned on the full fare tickets and I calculate how much money I earned on the reduced fare tickets, what am I going to do? I'm going to add those two up and set it equal to 1,196. And that's where our equation is going to come into play. Okay. So let's do that. Let's write up our equation. We got 32x plus 26 times the quantity 40 minus x equals 1,196. Guys, do I need to multiply by 100 here?
No.
No, there aren't any decimals, are there? Okay, so Joe Edwards, help me out with my first step.
You distribute 26 with 40 minus x.
Yeah, very good. 26 times 40. Now 25 times 40 will be easier to multiply, and then we could just add on an extra 40. 26 times 40 is going to be 1040. And 26x. Quentin, can you combine like terms, please?
32x plus 26x equals 58x.
That is a true statement. However, we're not plussing here. We're not adding.
32x minus 26x equals 6x.
Beautiful, 6x. And I'm going to go ahead and subtract 1040 from both sides as well, if you guys don't mind. And we'll get 156. Okay, so we combined our like terms. We subtracted 1040 from both sides. Last step would be to divide both sides by 6. Okay, so x equals, oops, 26. Okay, so just like we did in the last problem, we didn't stop when we got to y equals 10. We're not going to stop right here when we get to x equals 26. 26 is the number of full fare tickets. Okay, so there were 26 full fare tickets. If there's 40 altogether, how much does that leave over for the reduced fare?
14.
Yeah. You'll get the hang of this a little bit?
Yes.
Okay. Have y'all done many of these types of word problems? Rate times quantity equals total. Have you guys gone through any of these in y'all's classes yet?
Not really.
Yeah, not really.
Okay. One of the best things you guys can do when you're working problems like this is use that chart. Okay. You won't always have to use the chart. I mean, heck, in a couple of years, you'll be in Algebra 2 and you'll have, just blown on by the whole chart scenario. But for right now, I would recommend using a chart to help you guys organize the information. And because sometimes these are like what I would consider, quote, A-level problems, okay? You guys at Holy Rosary, y'all still using Orange Book, Dolciani structure and method? Quentin, y'all still using that textbook?
I think so, but I'm not sure.
Do you have an orange textbook?
No, I have a red textbook.
Oh, Joe Edwards got it. Joe Edwards has got it. Yeah, that's the one. Attaboy, Joe. The notion of in the way that they put practice problems in that book together is they call A-level problems, B-level problems, C-level problems, and they get harder as you progress through. So like an A-level problems, just kind of rote memorization. How do I do it, and can I do it quickly and accurately, right? So that's like what we've done thus far. We've been working on A-level problems. The B-level problems, they try and introduce maybe a slight curveball, but not too much, and they just make it a longer problem. Like they make it more involved with lots of more small steps along the process, okay? And then the C-level problems, they're breaking off at you and see if you can hang in there, okay? The C-level problems are a booty kicker, and so I like to try to get you guys to that level. I like to try to work C-level problems as we can. Here's a B-level problem. Okay, here's one that's going to involve a little bit of a different flavor. This is called a mixture problem. And the way a mixture problem works out is the exact same way that we've been doing thus far. It's rate times quantity equals total. Okay, so I'm going to set up my chart. Rate, quantity, total. Okay, we got raisins and nuts. So we got raisins And we got nuts. I just ate some raisins this morning. Yum, yum, yum. Nature's candy, as character on Parks and Rec would say. All right. So let's see if we can break down what we've got here. It says we're making a mixture. This person's going to go crazy and buy 25 pounds of trail mix. Maybe he's like a scoutmaster or something. Okay, so he's got 25 pounds of trail mix. So right off the bat, what column, Joe, does that apply to? 25 pounds of trail mix. You think that's going to be rate or quantity?
Quantity.
Yeah, absolutely, man. So like if the question down here, figuring out what the question's asking, step number 1 of our word problem solving method, if they say how many pounds of raisins and how many pounds of nuts, in other words, we want to know all about the quantity column, okay? Why don't I say let X be the number of pounds of raisins, and then here's the question for us, how could I express, I bet Charlie Griffiths can tell us, Charlie, how do I express the number of pounds of nuts? And don't say Y, say something, quote, in terms of X.
X plus,
Use the blue-eyed principle. If there's 25 kids in the room, 7 of them have blue eyes. 25 minus 7 is how I represent the non-blue eyes.
for the nuts. I don't know.
All right, how many pounds of nuts are there altogether? How many kids are in the room, so to speak?
25 minus 6.
That a boy. Very good, very good. So it's the whole 25 minus part 1. And that's how we would represent part 2. Guys, that is crucial. Okay, that's super crucial for us. All right, to be able to express both unknowns in terms of the same variable. Don't forget, that's goal numero uno for setting up our unknowns, right? Express both unknowns using the same variable. Okay, that's a hard challenge for us, but Charlie just helped us do it, so kudos. Good job, Charlie. Let's see, raisins cost $4.50 a pound, so I'm going to go ahead and put 4.5 there. Let's see here, nuts cost $8 a pound, so we'll put 8 there. Now we've got our chart almost finished up. Jake Oxley, what do I do?
Multiply from left to right.
Very good. We're going to multiply from left to right. Lewis, I see you got a question. Go for it, brother.
Does it matter, like, in the quantity column, which one is X and which one is 25 minus X?
Fabulous question. Fabulous question. It absolutely does not. Okay. I just happened to pick 4.5X because I knew that when I had to use my distributive property, I would rather distribute 8 times 25 and X as opposed to 4.5 times 25 and X. And that just helps me eliminate some extra decimals. But yeah, it doesn't matter. You could totally do it. If you wanted to let X be the number of nuts, then you could say 25 minus X is the number of raisins. Great question. All right, so anybody else with questions as we multiply from left to right? All right, like I said, that's an easy distribution, so I'm gonna go ahead and do that. So like, again, let me ask this question. Again, this might be a weird question, but like, what is 4.5X? This is the amount of money paid for raisins. Okay, and what is 200 minus 8X? That's the amount of money paid for nuts. And what are we gonna do? We're gonna take those two expressions, we're gonna add them up, and we're going to set them equal to the total amount of money paid, which I believe this mixture costs $6.60 a pound. Now, here's where you have to do a little bit of extra thinking, okay, fellas? Here's where you have to do a little bit of extra thinking. Should I just go ahead and say, let's set that equal to $6.60? Don't you dare set it equal to $6.60, because what is $6.60?
It's only 1 pound. You have to have 25 pounds.
Boom. 660 is a rate. So once in a while, I'm about to blow your mind here, boys. Once in a while, like with this mixture problem, for example, sometimes it is helpful to introduce an extra row an extra row for the whole mix. And if the whole mix costs $6.60, okay, and there's 25 pounds, just like what Drew said, or excuse me, Jake, what we would do is we would multiply from left to right. Okay, so if there's 25 pounds of this stuff, so there's a lot of trail mix, and it costs $6.60 a pop, then that's going to be $165. And what is that? That's the total amount of money paid for the mix. And that's going to be how we write up our equation. You guys see what I'm talking about there? So we've got, with mixture problems, we've got this extra step. That's why it's a B-level question, okay? We've got this extra step. Doesn't make it much harder. It just makes it a little bit longer, okay? So let's put together our equation here in blue, and we'll wrap things up for today. 4.5x plus 200 minus 8x equals 165. I really didn't need those parentheses, but I put them there just to distinguish that that was our second cell there on the far right-hand column. All right, let's put these together. We got negative 3.5x. Okay, so if I combine my like terms, 4.5 minus 8 is negative 3.5. Subtract 200 from both sides. And we get negative 35. Ooh, and that's going to work out nicely again. X equals what? What's 35 divided by 3.5?
10.
Yeah, very good. And it's a positive 10 because a negative over negative is a positive. So what did we just answer? We just answered how many pounds of raisins there are. There are 10 pounds of raisins. What does that mean there's going to be as far as pounds of nuts?
25 minus 10 equals 15.
Yeah, so we got 15 pounds of nuts. Now, this is a bit of a suspect question. I got to be honest with you. Most of these questions are pretty legit. This is not a very legit question. Because where are the M&Ms at, fellas? You know, where are the M&Ms? That's what I want to know. Raisins and nuts only? Are you kidding me? Trail mix? It's got to have M&Ms in it. Joe Edwards knows what I'm talking about. Attaboy. All right. Well, fellas, our time is up for today. You guys did a great job. We knocked out several examples today. I think we did 3 examples, which is pretty tight as far as a shortened class like this. So what we're going to do is tomorrow we're going to wrap up class. We're going to wrap up the week by jumping in and talking about some more mixture problems and some rate, time, and distance problems. So I've got some practice problems that I want you guys to spend some time working on that I will assign you tomorrow. In the meantime, have a great day. Be careful out in the rain and live Jesus in our hearts
Forever.
forever. All right, fellas, y'all be good.